Bismillahirrahmanirrahim. In this video we will learn how we can make the garage door opener by using the state table state diagrams in Proteus. So this is our problem statement, which is make circuit for the following garage door opener state machine using melee machine and simulate in Proteus using gates. So this is the state diagram of our garage door opener, in which we have the upper limit and down limit. Upper limit means the maximum upper distance the gate will open, and the lower limit the gate will close. And we have three inputs basically, which is our active, upper limit and lower limit, and we have three states A, B and C. Now we have to make the state table. Here on the screen you can see that I have made the state table for our garage door opener circuit, in which we have present states A, B, C, and inputs are activate, which means that whenever the activate is 1, our circuit will run. Otherwise, when activate is 0, no function will be performed. And upper limit, lower limit, and next states and output. We have two final outputs, move up and move down. Whether the garage have to move up to open the garage or to move down to close the garage. Here you can see that we have the following relationship when all the present states are 0, 0, 0, and we have activate, which is our don't care. So our activate is don't care. So whatever the input is, we always get the output 0, 0. And same is the case in the second row. Our activate is don't care, so we will get the 0, 0 output. And when our activate is also 0, in that case we also get the output 0, 0, because we only perform the operation when our activate is 1. Otherwise no function will be performed. So in the next cases, when we see when our activate is 1 and the upper limit and lower limits are don't care, so our function move up and move down, both outputs are 0, 0, because we don't know whether we have to move up or move down, because we don't know the upper and lower limits. So when we have the activate 1 and we have the upper limit, so we have to move down. In this case you see that in the second last column, you see that we have the present states 1, 0, 0, 0, and our upper limit is reached, so we have to move up, so our output is 1. So from this state table we have to make the K maps for our next state and outputs. Here you can see that I have made the K map for our next state A, which is DA, and I have derived the equation of the DA to make this circuit. And then this is the truth K map for our B state, and this is the equation derived from that K map. And similarly this is the K map for our C state, and equation DC derived from this K map. And finally we have our final outputs, move up and move down, which is equals to A, B bar, C bar, A, B, C. Now when you understand these state table and these K maps, you can very easily derive these equations and make the circuit of your garage door opener very easily. These equations are lengthy, you can see that, but these are very easy when you understand them. Now from these equations we have to make a circuit on Proteus. Now I will show you the circuit that I have made on Proteus. So this is the circuit of our garage door opener that I have made from the equations that I have shown you previously. Now this circuit is looking very difficult to you, but when you understand the equation that I have shown you previously, that are derived from the state table, when you understand that equation, then the circuit will become very easy for you to understand. Otherwise it will be very difficult to you to understand the circuit by just seeing in Proteus. Now when I zoom into the circuit, you see that this is our motor, which can move in both directions to show that whether the door is open or door is closed, motor up and motor down. And these are our three inputs: activate, UL means upper limit, and DL means down limit. And this is our then all the diagrams, and in which we have three latches for next states A, B and C. then this is the circuit. Now I will show you the circuit by simulating. Now you can see that when we have our activate state already on, and when we have the upper limit reached and down limit is 0, so our motor is rotating in clockwise direction, which shows that our gate is now moving down to close because upper limit is already reached. Now when I change the inputs, upper limit is now 0 and down limit is now 1 because down limit is reached, so we have to move the garage up, so our motor is rotating in anti-clockwise direction, which shows that gate is moving up to open. So in this way we can make our garage door opener. So now in this video you can see that how we can make the circuit of a garage door opener using the state tables. Then from the state table we have to draw the K maps for the present states, next states, and for the outputs, and by using these equations derived from the K map we can make our circuit of garage door opener that I have showed you there. Here I have made that circuit by using these equations, and then using the upper limit and lower limit our motor will rotate in clockwise direction or anti-clockwise direction, whether it is move up or it moves down. So that's enough for today lab. Thank you.